Hello students, myself Dr. Dinesh V Rojatkar. I'm working in the Department of Electronics Engineering, Government College of Engineering, Amravati. This semester, I'm going to teach the subject Digital Electronics, having code ETU 323. Dear students, this is an comprehensive course on understanding digital electronics. This course is to learn the digital format and data and codes. The course will help you understand number systems, numeric codes, logic gates, combinational circuits, and sequential circuits. Digital electronics is one of the branch of electronics. It deals with digital formats of data and codes. In this, only two conditions are possible: 0 known as logic, 0 known as low logic, and 1 known as high logic. Digital electronics may also refer to a portion of an electronic circuitry responsible for digital signal conversion. Some devices in this field include multiplexers, gates, and decoders. They are also composed of mathematical features and include phones, computers, and many products also. In simple language, we can say that digital electronics is nothing but dealing zeros and ones, where digital stands for digit. Digital electronics is the foundation of modern computers and digital communications. It is a complex digital logic circuit with millions of gates can build onto a single integrated circuit known as microprocessor, and these circuits can perform millions of operations per second. Digital electronics means electronic digital circuits represent signals by discrete bands of analog levels rather than by a continuous level. All level represents the same signal state. The continuous analog signals converted into a finite number of discrete states. That process is called as digitization. A small change to the analog signal level do not leave the discrete envelope, and the result are ignored by the signal state sensing circuitry. The number of these states is 2, and they are represented by the two voltage bands, that is one near a reference value and a value near to a supply voltage corresponding to a false or 0, and another is true, that is 1 value of a Boolean domain respectively. Digital techniques are very useful because it is easier to get an electronic device to switch into one of the number known states that accurately reproduce a continuous range of values. Digital electronic circuits are main thing in digital electronics, which is usually made from large assemblies of logic gates. The system which processes discrete values is known as digital systems. The significance of digital electronics is that are inherently more reliable than analog in terms of information processing. Though we are having analog system in existence, the question may arise that why we are using the digital system, and therefore we should see what are the advantages of digital system over the analog system. Some advantages can be mentioned as: first is the digital circuit when compared to the analog circuit are that signals represented digitally can be transmitted without degradation due to noise. For example, a continuous audio signal transmitted as a sequence of ones and zeros can be reconstructed without any error, provided the noise picked up in transmission is not enough to prevent identification of ones and zeros. An hour of music can store on a compact disc using about 6 billion binary digits. In digital system, information storage can be easier than in analog ones. Digital systems noise immunity permits data to be stored and retrieved without degradation. And the third advantage may be the noise degrades the information stored in analog system and in digital system both. As long as the total noise is below a certain level, then the information can be recovered perfectly. It is not the case that the noise is different for analog signal or digital signal. It is same for both. We will also see the rationale of the subject digital electronics, means why we require this particular kind of a subject. As we know, digital electronics is one of the important subject. Most students of electronics and computer background need to have basic understanding of digital electronics. This course this course help you to understand the basic gates, the design of digital circuit using basic gates, minimization of Boolean expressions using Karnaug's map, popularly known as K-map, and the logic gates. The course explains you about different number systems and different number bases which play a very important part in this world of computers. It can help students to study the circuits and make the practical possible application of the circuit in day-to-day life. The course content covered all topics of digital electronics, which is developed based on feedback from the students and the professionals. Explained in very simple language, the course is very easy to understand for beginners also. The course clears every minute concept of the digital circuit, making it very clear for the beginners. Digital electronics is also very important in today's life because of the digital circuit compared to analog circuit are that signals represent digitally can be transmitted without degradation due to noise, as we mentioned earlier. For example, a continuous audio signal transmitted as a sequence of ones and zeros can be reconstructed without error, provided that the noise picked up in the transmission is not enough to prevent the identification of ones and zeros, which is usually the case in case of a digital signals and not a usual case for analog signal. An hour of music can be stored on a compact disk using 6 billion binary digits. Also in digital system information storing is easier than that of analog systems. This course is having some goals and objectives. The primary goal is to prepare students for a successful professional career in the digital electronics. To get good knowledge of digital electronics. During the course, we can learn how to design the digital circuits using basic gates, K-maps, and logic gates to permit you to implement simple logical operations using combinational logic circuits. Also, you can learn different number system with different number bases, which plays a very important role in today's world of computers. Further, we will learn combinational logic circuits, its design and realization for various circuits like adders, fast adders, subtractors, multiplexers, encoders, decoders, parity generators using logic gates and MSI circuits, that is nothing but integrated circuit. We'll also learn various components of sequential circuits and will design and realize circuits like shift registers and various types of counters. We can learn building and fault finding of the circuits as well. At the end, we will also learn about the semiconductor memories. In the experimentation part, that is in the practicals, we'll learn how to test equipment including breadboard, multiplexers, oscilloscopes, logic probes, and the pulsars to implement these digital circuits. In simple words, the main objective is to make you awesome in the digital electronics and the circuits. Then question arises, what are the prerequisites for to learn this particular course? I would like to mention that there is no prerequisite to learn this course. That is, this course explains digital electronics, which includes topics as Boolean algebra, combinational circuit, sequential logic, basic logic, and gates. Also includes many other basics from crisp logic. For this course, there is no prerequisite. That is, no prerequisite knowledge is required. Also, knowledge in basic mathematics, basic calculus, and linear algebra will be added advantage. At the end of learning this course, what are the outcomes? That what you will get after learning this course. At the end of the course, after learning this course, the student will be able to first optimize the digital circuits by applying the Boolean algebra and other minimization techniques. The student will able to study, design, and realize the SSI, that is small scale integration, MSI, that is medium scale integration, and the programmable combinational circuits and sequential circuits using flip-flops like counters and shift registers. These are the outcomes. Other advantage of this course is that this course is also useful for the gate. You will find 2 to 3 questions on this topic in the gate examinations, and giving correct answers to 2 to 3 questions is very important in the examination like gate, that is graduate aptitude test in engineering, which every engineering student should appear and should qualify. Now the question arises that from which book we can learn the syllabus. Most of the syllabus could be found in the following books. The very preferred book for to learn this subject is Digital Principles and Logic Design by author Saha and Manna by Infinity Science Press. The another useful book for this course is Digital Design by Maurice Manu, which is published by Pearson Education, year 2018. Another book preferred by the student is by T.L. Floyd, Digital Fundamentals, 11th edition, Pearson Education 2018. As we are practicing that every year, the course which is being taught, we ask students to purchase a book that they prefer. And if the book is available with the student before and after the lecture, they can refer things and they can learn the subject effectively. Now, how we are going to learn this subject? This subject will learn with 3 lectures in a week. The total credit to this course is 3. This course will be evaluated with 30 marks in MSc, that is mid semester examination. 10 marks will be 10 marks weightage is for the teachers assessment, and there will be 60 marks paper in end semester examination, that is ESE. In this way the total 100 marks will be evaluated. From your career point of view for doing MTech, and in all sense also this is very important course. This semester, due to COVID-19 situation, we will learn this course through online mode, probably on the Cisco WebEx, starting from 17th of August 2020. I hope meantime we will collect the books and other resources required for learning this course through the online mode. See you then on 17th August. Bye. Thank you.